Hey, so let's do the Unit 1, Lesson 2 practice problems for Desmos. They usually start with these little like warm-ups or basic multiplication or division or whatever. So let's do these real quick. You're being asked to figure out 8 times some number, some blank equals 40. If you can fill that out with your head, that's great. But if you can't, you can always reverse the operation. So you've got this calculator button up here at the top of the Desmos screen that you may or may not have even noticed at this point. And so if we're trying to figure out 8 times blank equals 40, well, luckily multiplication and division, they work in reverse of each other. And so we can just reverse the operation. We can do 40 divided by 8. You can type rather than actually pressing the buttons over here. And we get 5. So 8 times 5 is 40. Now, the same thing works here, just the numbers are reversed, right? We're still going to do 8 divided by 40 to figure out what goes in that blank. Just this time it's 8 divided by 40 instead of 40 divided by 8. Oop. And the answer it shows is 0.2, but I want to show you something. If you hit this button here, it'll give you the fractional answer instead. And it's 1/5, which is important because look, when it was 8 times blank equals 5, which you could think as 5 over 1, when we switched the numbers around and said now it's 40 times blank equals 8, then the answer flipped, right? It became 1/5. If you've been practicing keep, change, flip in class, and you don't really understand why it works, like you're doing it, but you're like, why is it that we can flip the numbers and change the multiplication, this and that? Well, we'll talk about that later in the school year, but this should kind of give you a hint, right? Like, oh, wait, 5 over 1, 1/5, the multiplications got reversed. Try to think about it a little bit. All right, so here we got 21 divided by blank equals 7. Another way you could think about this is like just 21 divided by 7 equals what? Like if I break 21 into parts of 7, how many parts am I going to have? And it's going to be 3. And then the last one, we're just changing from division to multiplication. That's essentially the idea of keep, change, flip. And so I know that it's 1/3, right? If you take 21 and divide it into 3 parts, you get 7. Or in other words, 21 times 1/3 or 1/3 of 21 also equals 7. Those two things are just different ways of saying the same thing, really. All right, let's move on. Select 3 triangles that are scaled copies of triangle T. So I would start by just remembering that scaled copies have to maintain the same shape as their original. And so just based off of that, I wouldn't be selecting A or F because like, see how they don't even have a right angle over here on the side? They're like more slanted. So I'm confident that those aren't scaled copies. The rest of them look like they could be scaled copies. So we have to think a little deeper about it. We're looking for scale factor on each one of them. We're looking for a common ratio between the side lengths of triangle T and whichever one we're checking, whether it's B, C, D, or E. You could think of it as a common ratio, or you can think of it as like a number that you could multiply by the sides of T and get the sides of whichever triangle you're looking at. So B is pretty obvious, right? Because it's all the same numbers as triangle T. So that means it's a scale copy. It's actually an identical copy, which means the scale factor is 1. 1 times 4 is 4. 3 times 1 is 3. 5 times 1 is 5. So it's the most basic scale copy you can make. Now, if you look directly below that to triangle E, that's like the second most basic scale copy you can make. Because look at what the scale factor is. What do you have to multiply 4 by in order to get 8? What do you have to multiply 3 by in order to get 6? What do you have to multiply 5 by in order to get 10? Hopefully, as I was talking through that, you realize that it's going to be 2 for all of those. And so E is a scale copy with a scale factor of 2. Now, D is a little bit harder because we got these decimals, and it might not be so easy for everyone to like figure out what number times 3 equals 4.5 and what number times 5 equals 7.5. And so we have a secondary like method for this process when that happens. And that's all based on division. We want to see, is there a common ratio between the side lengths of triangle D and triangle T? And so we just divide rather than trying to figure out like what number can I multiply by, we just divide. It's the same as the warm-up, right? The warm-up If you couldn't fill in the box, figuring out something times blank equals something, then you just divide. So let's do that for each corresponding pair of side lengths here. The 6 in triangle D corresponds to the 4 in triangle T. So I'm going to do 6 divided by 4, and I get 1.5. So as long as the other two pairs come out to 1.5, then we have a scaled copy. If I get anything other than 1.5, then we don't. Let's see here, 4.5, I'm doing the bottom of triangle D, divided by the 3 at the bottom of triangle T, 1.5. And let's do the hypotenuse of triangle D, 7.5, divided by the hypotenuse of triangle T, which is 5, and we get 1.5 again. That's enough to make me confident that D is a scaled copy, and its scale factor is 1.5, which is going to be important for the next slide. All right, so the only one we haven't really considered yet is triangle C. Triangle C looks like it could be a scaled copy, but I think when you run the numbers, you'll see that it's not. Let's do the side of triangle C divided by the side of triangle T, which is 4. You get 1.25. But if we run the bottoms of triangle C and T, so that'd be 4 divided by 3, we get 1.3 repeating. And so the ratio is not constant, or they don't share a common ratio between these corresponding side length pairs. And so, nope, we're not going to click triangle C. And so on the next page, it's just asking us what the scale factor was for the 3 triangles that we chose. And we've already done that work. We already know that B has a scale factor of 1, right? All the side lengths of triangle T times 1 equals all the side lengths of triangle B. Triangle E has a scale factor of 2 because all of the side lengths of triangle T times 2 equal the side lengths of triangle E. Sorry, I'm in the D box here, but I want there. And then with D, you should remember that I did all those divisions and they all come out to 1.5. So there we go. That because all those divisions, when they all come out to the same number, that tells you that that number is a scale factor. So we already did that work on the previous screen. All right, the next problem says, use what you know about area to determine the area of triangle T. So area, in case you've forgotten, is the space that a shape or an object, well, I really shouldn't say object because then we'd be talking about volume. So the space that a 2-dimensional shape or object takes up, all this. So not perimeter. If you're thinking about perimeter all the way around, that's not it. Geez, I can't even color in the lines. So one way you could do it is just counting the boxes. The number of boxes that it takes up is its area. But the problem with that is see how it kind of cuts through one of these boxes here, and like not even nicely, it cuts kind of through a weird area here, and then it has this tiny little sliver of this box. So it'd be really hard to count up the perfect number of whole boxes that it takes up. So instead, there's a formula you could use, but what I like to do instead is think of it this way. If I were to make a rectangle like this, I should use the line tool instead of this, but whatever, it's not a big deal. That connects the 2 opposite vertices of the hypotenuse of the triangle, then the triangle cuts this rectangle that I just drew perfectly in half. And so if we can count all the boxes in the rectangle, the triangle must take up exactly half of those boxes. So look at the boxes inside the rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Half of that is 6. So the area of that triangle is 6. And we move on. All right, here you're being asked to do something similar to what we did in class. If you're watching this the year that I made this video, might do something different in future years. But today in class, I asked you to make your own little drawing and then make a scale copy of it. And that's the same thing here. They just want you to make any triangle. It doesn't have to be perfect. Let me use the line tool rather than the pencil tool. I'm going to make my life easy and make a right triangle. Those are always easier to draw. So let's see here. I guess it's not really going to turn out right. It's almost right. And then we can use the text tool up here. We got to label some side lengths. So mine, I would say kind of looks isosceles. It kind of looks like this side here. I know I'm just going to make up a random number. I'm going to say this is 4. Is about the same as this side here, so I'll call it 4, but this one's probably a little bit longer. So let's call it 5. And now I'm going to draw a triangle over here that is a scaled copy. And I'm gonna challenge myself. I'm gonna use 1/2 as my scale factor rather than something easy like 2 or 3. And so if I use a scale factor of 1/2, that means that everything over here should be about, or should be exactly half as long as it is over there in the blue triangle. So I'm kind of estimating right now, trying to make this about half the size. And then all the dimensions have to be labeled as half. So the 4s are easy. Half of 4 is 2. Half of 4 is 2. 5 is a little bit harder, but if you can't do that, we always got our calculator button up here. 5 divided by 2 equals 2.5. So I'm going to put a 2.5 there. And there's my original triangle and my scaled copy made with a scale factor of 1/2. Okay, Brianna says figure 2 is a scaled copy of figure 1. Do you agree with Brianna? So take a look at it for a second. So here's what I want you to notice, or what I hope you noticed about it, like almost immediately, is that figure 2 is the same width as figure 1, but it's shorter. You can't do that with a scaled copy. You can't reduce its height without also proportionally reducing its width. So in other words, it's squished, right? That's a very mathematical term there. It has been squished. And in scale copies, you are not allowed to have any squishing. So I'm going to say no, I don't agree with Brianna. And my reasoning would go something like this. The height of, of figure 2 is less than that of figure 1, but the width is the same as figure 1. That just in and of itself is enough to explain how you know the figure 2 is not a scale copy of figure 1. We should submit that, move on to the next one. And the last one is the explore question. Sometimes when I assign these homeworks, I will tell you that the explore is like optional or extra credit, because some of these can get pretty hard. This one's not too bad. We just got to use what, 2, 4, 6 of these digits down here to make a scale copy relationship between the blue rectangle and the green rectangle. A smart way to do it is to pick relatively small numbers for the blue side. So you leave yourself bigger numbers for the green side. You just got to be thoughtful about what numbers you choose, because you can't duplicate anything. Once you use a digit, it's gone. I know that if I put the 2 and the 3 here, nope, not the 3, the 4, 2 and the 4. If you use a scale factor of 4, meaning you're going to multiply both of these by 4 to fill in the side of the green rectangle on the top, you should be able to fill this in using 4 of the remaining numbers. And so I'm not going to tell you what numbers those are. You should be able to figure that out at this time. Use the 2 and the 4 as your sides of your blue rectangle, and then use a scale factor of 4 to fill in the green box. All right, and the last page just asks you, like, what are you proud of, or what did you think of this homework? You can fill that part out if you want or not. I'm not too concerned about it. Mr. Wong, or if you have a different math teacher than me, might feel differently about that. So do whatever they've asked you to. All right, I'll see you.